Good day to you, dear students, and I want to welcome you back to class once again. Today we are going to continue from where we stopped, that is trigonometry. The last class we had, we talked about Sohcahtoa, that is sine is equal to opposite over hypotenuse, and cos is going to be equal to adjacent over hypotenuse, and your tan is equal to opposite over adjacent. And we had few questions on that we solved, and I gave you classwork. I want to appreciate those that did the classwork and sent to me. We have that, it has been discussed, and we are actually growing. If you have not been partaking in it, please join us. Just send your classwork to the WhatsApp page that is under this, that is scrolling on the screen right now, so you can you can be part of the class, so we can grow together as well. So here, I just want us to see what problems on the real life wahala of trigonometry, or especially Sohcahtoa specifically. Look at this. This question is a why question, objective. So, and I've seen series of questions like this in JAM. So relax. This is practically WAEC, NECO, JAM, research syllabus. So let's work. A ladder 9 meters long leans against a vertical wall. Of course, we know a ladder cannot stand alone except it lays on something. So leans on a vertical wall, making an angle of 64 degrees with the horizontal ground. Please note that with the horizontal ground. Calculate correct to one decimal place how far the foot of the ladder is from the wall. So what you would do first is to draw a picture of how the ladder is laying against the wall and the ground. I have been telling my students that something like this is basically a pictorial question. It's just pictorial. So if you're an art or a science or a commercial, all you need to do is to get the picture. Just get the picture. The question is saying solution now. The question is saying that a ladder lays on a vertical wall. So this is the wall. It is a vertical wall. Sorry. Let me have my vertical wall now. Good. And this is the ground. So it's leaning against the vertical wall. So this is the ladder. And the ladder is 9 meters against a vertical wall with the horizontal ground. With the horizontal ground, that is 64 degrees. Calculate correct one decimal place how far the foot of the ladder is from the wall. This is the wall. So how far? So we are solving for this side. So what do we do? Then we think. Best thing here, Sohcahtoa. We have, this is our angle. Obviously, this is our opposite. We discussed it the last time we had a class. Then this is your adjacent. So once this is your adjacent, we all know this is our hypotenuse. So adjacent and hypotenuse, that is car. So we have cos 64 is equal to adjacent x over 9. So our x is going to be 9 times cos 64. So our x is equal to 3.9, 9 times cos 64 meters. That is the solution. So that is all we have. You don't need forever to solve this. As a matter of fact, I know some students who does not need to draw it because it's an objective question. What they need to do is to just press calculator, pam 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 pam, and they get the answer, tick, then they move on with the question. So that is for question one. I have another question to give. That is another why question. I'm thinking of we discussing two more word problems, then we move from there. The angle of depression of a boat from the top of a cliff is 58 degrees. If the cliff is 10.5 meters high, how far is the boat from the foot of the cliff? Let me explain what depression means before we continue. Yeah, depression, and elevation, as the case may be. Elevation is when you look up to something. Maybe the object is up there, you are looking up. Like I have something up here. This that I'm looking at this direction, it means I am elevating the object. I'm elevating the object. I'm looking up to the object. But when I look down at an object, I am depressing the object. I'm depressing the object. As a filmmaker and as a cinematographer, I would always use that as an example. If I have a character here and a child is here and I'm standing here to talk to the child, camera will look to be positioned this way to elevate me and be positioned this way to depress the character. So as the case may be, oftentimes that is elevation and depression. So here we have angle of depression of a boat from the top of a cliff is 58 degrees. If the cliff is 10.5 meters high, how far is the boat from the foot of the cliff? Picture first. Let's see the picture you have, then we continue from there. A boat, obviously a boat cannot be up here. It's obviously on the sea, on the ground. So I have a boat here. I don't have to draw a boat. All I need to do is to fix the position of the boat. So this is my boat here. So we have from a cliff here. We have a cliff here. So I have a cliff here. So they say the angle of depression of the boat from the cliff, from the top of the cliff. So the angle of depression. So angle of depression, most time you will relate the height of the character, along with the place is looking at. So the height of that character. So that is the hint there. So anytime you have angle of elevation, angle of depression, it is about the height of that person or of that object. So this is the top, from the top. So this has a height. That's what I'm trying to say. Then with the angle of depression. So this is my angle, 58 degrees. A lot of people will put the angle here because the depression is wrong. It is very wrong. Your angle is related to the height. So it has to be here. Of course, angle of elevation is always equal to angle of depression. So that is where it is easier in a way to work with. So even if you don't know what you do, like a smart student, if you don't know if you have to put it here or here, don't bother, just put it here. It's going to be the same thing. You can work with it. Or if you take this one from 90 degree, that is 32. That is 32 here. You can use this 32. But in order not to disturb you, or to confuse you, this one is often equals to this one, or always equal to that one. They call it angle of elevation, which is always equal to angle of depression. So the cliff is 10.5 meters. The cliff is 10.5. So how far is the boat from the foot of the cliff? How far is the boat from the foot of the cliff? We are solving for this as well. So from here we have opposite over adjacent. That is O and A. OA. So once we have OA, that is that's tangent. That is tan 58 is equal to 10.5 over x. So I will have my x to be, if you cross multiply, my x to be 10.5 over tan 58. So once we have this, our x will be equal to, we have 10.5 tan 58 is 1.6. So my x is equal to 6.56 meters. So to correct to, do you have anything to correct to? Nothing. How far? So if you can correct this one to one decimal place, so we have x is equal to 6.6 meters to one decimal place. That's all. So from here, angle of depression, this angle of depression, this is the angle of depression. From the top of this to the boat from the top. So it's what we have here, which is equal to this one, and the height of the cliff is this. We are asked to solve this, which is 6.6. Using Sohcahtoa for these two questions has been a wonderful thing. So there's still one more question I would love to talk about. That is purely WAHEC question that is very, very interesting.